Hello, everybody. So I'm Trinidad, and I'm going to be your host for our talk on microplastics and their impact on health. We plan to interview people around Ateneo, specifically here in Sequoc or RBR, to ask them where do they get their beverages in relation to microplastics in drinking water.
I'm Danny from MS Bio.
Hello, Danny from MS Bio. This is very fitting actually to your course. So where do you usually get your drinks?
I usually get my drinks in Gone, so I usually get Juicy Juice or the coffee there, either in the convenience store or in Day Off.
We get them in cans.
Where else?
Cans and glass bottles, nowhere else.
Gone's, I always drink coffee there, and water from the water fountains.
Around like 7-Eleven or from groceries. But if it's in school, maybe around Gons or Jason.
So are they usually canned or bottled?
Usually, most of the time they're canned and in plastic bottles.
Oh, my drinks? I usually get them outside of Coco or just like vending machines.
Oh, so are they usually bottled or canned?
Usually bottled.
Okay.
Water bottles,
Water bottles? Okay, where do you purchase them usually?
guns too.
Do you get your drinking water at home or at school?
So it depends. Usually I bring my own drinking water from home. So we have a distilled water tank there. But in school, I just use the water fountains on campus.
Usually from the drinking fountains found in Ateneo.
Usually here, since I don't want to deplete my water at home. So it's better to get water from the campus.
I usually get drinking water at home. I bring from my house already, but when I need to refill, I refill here at school.
Oh, I stop by my gym. I refill my water there usually.
So it's through a water fountain.
Yeah, the blue ones.
Oh, are you aware you've actually been drinking microplastics?
No! Where?
It's all around us.
No, but that's kind of unexpected outcome.
Yes.
How do you know?
No, not at all.
I'm pretty aware.
To what extent are you aware? Like how much microplastic you're consuming?
Oh no, I'm not aware how much I'm consuming. I just know that I'm consuming them.
Okay. But do you know from where in these drinking sources?
No.
I've heard.
To what extent are you aware like the amount you're consuming or where you get them?
Just acutely aware. Like I know it's somewhere there. I don't know.
If you want to know more about this and know how we know, join our talk about microplastics. It'll be on Zoom.
Oh,
Yeah.
Yeah, sure. I'll be there.
Thank you.
But yeah, I'm pretty interested.
Sure.
Thank you.
Sure, that's nice. My thesis is actually microplastics.
Really?
Yeah.
Okay, maybe we could get your research. We should share our research with each other.
Freshwater macroinvertebrates, the insects. So it's also like related to water, but surveying the insects that live in the water.
Oh, and how they consume microplastics. Okay, that's interesting. Perfect. This is fated, guys. Hello, everyone. Thank you for joining our talk. Let's begin by asking, what exactly are microplastics? Microplastics are defined as extremely small plastic fragments, typically measuring less than 5 millimeters or 0.2 inches in length. They do not represent a single type of material, but rather a diverse range of compositions, shapes, and sizes. They are generally categorized into two types. Primary microplastics, which are tiny particles designed for commercial use, such as microbeads found in personal care products or fibers from synthetic textiles. Secondary microplastics, particles that result from the breakdown of larger plastic items, like water bottles, fishing nets, and plastic bags, due to environmental exposure like sun radiation and ocean waves. Now, why are they a concern in drinking water? The presence of these particles in drinking water is a growing focal point for environmental and public health research for several reasons. Let's give an overview. First, indigestion. Because of their size, they easily bypass standard wastewater treatment filtration systems. Second, chemical leaching. Plastics often contain additives, like stabilizers or flame retardants, that can leach into the water. Third, pathogen carriers. Microplastics can act as rafts for bacteria and other microorganisms, potentially introducing pathogens into the water supply. You may be asking, how is this relevant globally? Let's talk about tap versus bottled water, for example. This is not a localized issue, but a global phenomenon. Research has indicated that microplastics are ubiquitous in our water sources. This means that they can be found everywhere. In our bottled water, for example, studies have found that they often contain higher concentrations of microplastics than tap water, likely due to the bottling process itself and the degradation of the plastic packaging. In tap water, even treated municipal water has been found to contain plastic fibers, though often at lower levels than bottled alternatives. According to the National Ocean Service, or NOAA, these particles have been found in every corner of the globe, from the deepest points of the ocean to the most remote freshwater lakes, making the filtration and study of drinking water a critical priority for future sustainability. We have invited 3 experts: Beatriz, Biscocho, an environmental chemist, Sasha, a water process engineer, and Leonard Liu, an environmental toxicologist, to cover the topics of microplastics and to give more clarity on how it affects our drinking water. I now call on Ms. Beatriz Biscocho to discuss the sources of microplastics.
Good day, everyone. My name is Bea, and I'll be tackling the various sources of microplastics, or MPs. These particles come from a wide range of origins, including plastic pellets, laundry wastewater, and the breakdown of larger items like plastic bags, bottles, and fishing nets. While sources like tire wear are major contributors, the environment is currently dominated by the massive volume of diverse plastic waste, according to Anne et al. 2020. But again, how did these particles become so pervasive? Well, one significant reason is our increasing use of personal care products. This has created a hidden pipeline of plastic pollution flowing directly from our homes into the ecosystem. Microbeads are tiny processed MPs used as replacements for synthetic pigments to help with cleansing, whitening, and exfoliation. You can find them in everyday items like facial cleansers, toothpaste, and sunscreen. And because they are small, insoluble, and slow to degrade, they easily enter the sewage network through our wastewater. But this flow from our bathrooms is just one example of how microplastics have silently woven themselves into our lives. The issue is that most modern treatment plants cannot effectively filter these beads out, and according to Hedgme et al. 2024, they often settle into sewage sludge, which is used for farming, therefore turning our bathroom luxury into a long-term soil contaminant. This contamination is a growing reality in the Philippines. A study in Iligan City revealed significant microplastic pollution in agricultural soil, suggesting human activities in waste disposal are major contributors. And according to Bacosa et al. 2024, plastics like polyethylene and polyproline in these soils point to sources like packaging and fertilizers. These findings prove MPs are not just in our water, but are deeply embedded in our food-producing lands. This is even more critical due to our country's limited sewer systems, as untreated wastewater is often dumped directly into water bodies, such as lakes, seas, and this is all according to a study by De La Rosa in 2024. This lack of infrastructure allows microplastics to bypass safeguards and enter our environment immediately. Ultimately, our daily routines and the state of our infrastructure here in the Philippines are just as responsible for the plastic crisis as industrial waste. So that's it for my talk on the sources of MPs. Thank you, and I will now turn it over to the next speaker.
Thanks for that, Bea. Now that we have heard from Bea about the sources of microplastics, let's talk about how it gets to the very water we drink. Our drinking water is typically sourced from 2 main sources. The first one are surface water sources, which include rivers, lakes, and reservoirs. The second one are groundwater sources, such as underground aquifers. Microplastics make their way into surface water sources via wastewater discharge, as well as rain or snow melt that flows over streets, driveways, and more. This is called stormwater runoff. The transfer of air pollutants, which is also called atmospheric deposition, is also another way it goes into surface water. For groundwater sources, this includes agricultural runoff, or situations such as the shedding of synthetic fibers, car tires getting worn out, and the breaking down of plastic waste getting into the soil. Poor sewage treatment is also a factor. The infiltration of contaminated surface water through soil is also a common pathway for microplastics to enter groundwater. Bottled water is a major source of plastic ingestion, with contamination occurring during production, bottling, and through the breakdown of the bottle itself. While a 2018 study, synthetic polymer contamination in bottled water by Mason et al. Estimated an average of 325 particles per liter, a 2024 study, rapid single particle chemical imaging of nanoplastics by SRS microscopy by Chen et al. Utilizes the improved detection methods which found that the actual concentration can reach 240,000 particles per liter. This discrepancy is due to the presence of nanoplastics. These are even smaller than microplastics. And this is something that older studies could not identify. But it now accounts for the bulk of plastic content in bottled water. Other things to consider are the friction that happens when opening and closing caps made of polypropylene, the breakdown of PET plastics caused by sunlight and heat, and the risk of contamination during the bottling process itself, like mentioned earlier. All these factors contribute to a higher level of microplastics in bottled water. The environmental cycle of microplastics include the ongoing release, movement, and build-up of plastics in land, water, and air systems. These mainly come from broken down large pieces of trash or industrial pallets and microbeads. Among the different ways it can go through the sources, such as the ones mentioned earlier. These particles move through wind and water, gathering in soil and ocean sediments. They can last for hundreds of years, carrying pollutants and making their way into the food chain. Next, we will have our expert Leonard explaining the health impacts it has on us. Thank you.
Now, since we know how microplastics make it into our bodies, what are the actual effects of microplastics on it? Well, first of all, microplastics can be found all throughout our body. Researchers have found particles within our various organs and their process and during their operations, not limited to our brains, hearts, stomachs, urines, and more. Though most ramifyingly of all, the meconium, which is in TLDR, baby's first poop, which is where, in the words of Labode, we are born pre-polluted. Other than that, a major concern stemming from our unintentional ingestion of microplastics is that their microscopic size allows them to pass through and accumulate in the previously mentioned organs, increasing the likelihood of triggering inflammation and plaque buildup, impeding our bodily functions. Another issue involving the chemical risks associated with microplastics in our bodies is that the plastics polluting our bodies contain indigestible compounds such as plasticizers, stabilizers, and colorants. All of this whilst also being exposed to and carrying over other outside and potentially more harmful chemicals, which could and would impede our normal biological functions due to them being abnormal and unhealthy for our bodies. In addition, though the research is incomplete, links between microplastics and certain bodily diseases and disorders have been found, including the dysfunction of the liver and intestines, reproductive cell quality decrease, autoimmune diseases, thyroid cancer, etc. And to reiterate, take this information with a grain of salt, as these concerns still require more long-term studies to fully understand the extent of these risks, though it is proving difficult to do so, especially in the search for a control group due to this widespread issue. On top of all of that, bioaccumulation is another key factor to consider. Bioaccumulation refers to the previously mentioned gradual buildup of microplastics within the body over time, aka plaque, which can also be known as plaque. Since plastics are notoriously hard to break down, or eliminate, repeated exposure to plastics in modern-day society is inevitable, leading to it being concentrated in our tissues. Though unnoticeable for most people in the present, This constant accumulation over time could amplify previously mentioned health concerns, making even a small amount of exposure still a medical concern.
Now, let's move on to some possible solutions and what we can do moving forward. One important solution is improving water filtration systems, both at home and in industries. Advanced filtration technologies can help remove tiny plastic particles from drinking water before they reach consumers. At home, using water filters with activated carbon or osmosis systems can reduce the amount of microplastics we may ingest. On a larger scale, industries and wastewater treatment facilities can invest in upgraded filtration systems that are designed to capture smaller contaminants more effectively. Another major step is reducing our dependence on plastic products, especially single-use plastics. Everyday items such as plastic bottles, straws, food packaging, and shopping bags contribute heavily to plastic waste. Over time, these materials break down into microplastics that eventually end up in rivers, oceans, soil, and even our drinking water. By switching to reusable bottles, eco bags, metal straws, and sustainable packaging, we can help lessen the amount of plastic entering the environment. Several countries have already banned microbeads in personal care products like facial scrubs and toothpaste. Policies that promote recycling, proper waste disposal, and reduce plastic production can greatly limit future contamination. Stronger environmental laws and better waste management systems are especially important in countries where wastewater treatment infrastructure is still limited. Lastly, individual actions still matter. Simple habits like disposing of waste properly, avoiding unnecessary plastic purchases, supporting eco-friendly brands, and being mindful consumers can collectively create a positive impact. While microplastics are now widespread, awareness and consistent action can still help reduce their effects on both the environment and human health. Thank you so much for listening, and we hope this talk helped everyone better understand the growing issue of microplastics in drinking water and why solving it requires both collective and personal responsibility.
So, how did the talk go?
It was very informative. I did not know that I was still drinking microplastics, even though I was averting any form of plastic bottles.
And what else did you learn from the talk anyways?
I learned no matter how hard we try to avoid microplastics, where we usually get our food and water already has them. So we're cooked. Oh, we're cooked.
We are. So, how's the talk? Oh, it's good. I learned a lot. I learned that I should stop intaking so much plastic because it might damage the water source.
I found that microplastics in my drinking water is actually very alarming, especially since I drink a lot of water on campus. And then upon listening to the talk and hearing about the different negative effects that microplastics have on the body, of course, I'm really worried, and I wish or I hope that the campus, or at least like whoever is in charge of the water here, would address it soon. But otherwise, it was a very informative talk.
It was very informative. I learned a lot about microplastics and how areas in the campus make us vulnerable to microplastics. So I think it also points to other ways that the administration or maybe the student body can also do to help mitigate the health impacts of microplastics in our water systems.